Imagine a solar eruption so colossal that it dwarfs our entire planet, extending tens of times Earth's diameter into space. These aren't scenes from a sci-fi movie. They're real solar flares, the sun's most powerful explosions, capable of disrupting our technology and illuminating our skies with breathtaking auroras. Solar flares are intense bursts of radiation resulting from the release of magnetic energy stored in the sun's atmosphere. They occur in active regions around sunspots, where intense magnetic fields penetrate the photosphere to link the corona to the solar interior. To grasp the sheer magnitude of solar flares, consider this. A solar eruption captured by the European Space Agency extended about 35 times the diameter of Earth into space. These colossal events can release energy equivalent to millions of nuclear bombs detonating simultaneously. Solar flares are categorized based on their X-ray brightness in the wavelength range of 1 to 8 angstroms. The classes are A, B, C, M, and X, with each class being 10 times more powerful than the previous. An X-class flare is the most intense, capable of causing significant disruptions to Earth's communications and power systems. In May 2025, the Sun emitted an X2.7 class solar flare, the most intense of the year, leading to potential radio blackouts, GPS disruptions, and increased chances of vivid auroras. This activity coincides with the peak phase of the Sun's 11-year solar cycle, raising concerns about further solar flares and geomagnetic disturbances. Solar flares can have profound effects on our planet. They can disrupt radio communications, affect satellite operations, and even impact power grids. The increased ionization in Earth's ionosphere during a flare can lead to degraded GPS signals and increased drag on satellites, potentially shortening their operational lifespans. One of the most powerful solar flares ever recorded was the Carrington event in 1859. This massive solar storm caused widespread auroras and disrupted telegraph systems. If a similar event occurred today, it could potentially knock out power grids and communication systems, causing chaos in modern society. Solar flares can also produce coronal mass ejections, CMEs, which are huge bursts of solar wind and magnetic fields rising above the solar corona or being released into space. When these CMEs collide with Earth's magnetic field, they can create geomagnetic storms, leading to beautiful auroras, but also potentially damaging technology. The Sun goes through an 11-year solar cycle during which solar activity, including flares, increases and decreases. During the solar maximum phase, the Sun is more active, resulting in more frequent and intense solar flares. Scientists monitor solar activity closely to predict when these flares might occur and how they could impact Earth. Understanding solar flares is crucial for protecting technology on Earth. Satellites in orbit are particularly vulnerable to the radiation from these flares. When a flare occurs, it can disrupt satellite operations, leading to issues like GPS inaccuracies, communication failures, and even damage to the satellite's electronics. Space weather forecasting has become an essential field of study. Scientists use a combination of ground-based observatories and space missions, like the Solar Dynamics Observatory, to monitor the Sun's activity. By analyzing data from these sources, researchers can provide warnings about potential solar storms and their effects on Earth. The beauty of solar flares is not just in their power, but also in their visual spectacle. When viewed from space, these flares appear as bright, glowing bursts of light, often accompanied by intricate patterns and shapes. They are a reminder of the dynamic and ever-changing nature of our Sun. In addition to their impact on technology, solar flares also have implications for astronauts in space. Increased radiation from solar flares can pose health risks to astronauts on missions outside of Earth's protective atmosphere. Space agencies take these risks seriously and have protocols in place to protect astronauts during solar events. As scientists continue to study solar flares, they are also exploring their potential connections to climate change. Some researchers suggest that solar activity may influence Earth's climate patterns, although this is a complex and ongoing area of research. Solar flares are powerful phenomena that showcase the Sun's energy and magnetic activity. They can disrupt technology, create stunning visual displays, and even impact human health in space. As research continues, the mysteries of solar flares will unfold, revealing more about our Sun and its influence on life on Earth. The next time a solar flare is reported, it will be a reminder of the incredible forces at play in our universe. So keep an eye on the sky and stay tuned for updates on solar activity. Who knows what spectacular displays the sun has in store? Whether it's a dazzling aurora or a powerful flare, the sun's fireworks are always worth watching. Stay curious and keep exploring the wonders of our solar system.